So let's look at our third type of equation, the exponential equation. An exponential equation is going to have no logarithm in it, and it's going to have a variable in the exponent. So let's notice down here that we have a base, and then the exponent has our variable in it. So this is exponential. So first thing we're going to do is isolate the base and its exponent on one side. So this part right here is the base and its exponent. Then we'll apply either the natural log or log, the log base 10, our common log, to both sides. Move the exponent to the front of the logarithm and solve normally. Okay, so let's see how this works. First of all, here is my base and the exponent. These two things are inseparable, so remember that they are inseparable at the moment. You can't divide by 3 and get rid of that base, all right? Those two go together and have to stay together. So think of them like an X. They've got to be together, all right? So we've got to get rid of the stuff that's with that base and its exponent. So we've got to get rid of the 5. So let's add 5, and we're going to get the base and its exponent by itself on one side. So now we have that base and its exponent by itself on one side. We've got step 1 done. We're going to apply a logarithm to both sides, and it always goes in front. So I'm going to put the natural log in front. We can also use our common log if we want. We just have to be consistent on both sides. We have to use the same log. All right, now step 3, move the exponent to the front of the logarithm. Here's my exponent. I'm going to move it out to the front of the logarithm. Now, since there's more than one item in my exponent, I need to put it in parentheses as it goes out the front. If it was just one term, I wouldn't need to do that. But because it is more than one term, we've got to put it in parentheses. All right, now we've got these logarithms in here, and it says the next step says solve normally. And you might think, well, how am I supposed to solve normally? But natural log of 3 and natural log of 17 are numbers. We can put them into our calculator and we can get a decimal approximation. So let's do that. Let's put them into our calculator. If I put natural log ln of 3 into my calculator, it gives me, and I'm going to probably take them out about 4 decimal places, so 1.0986. And then natural log of 17, 2.8332. All right, now notice it's a normal linear equation. We've just got ugly numbers in it. So let's distribute the 1.0986 through these parentheses. So 1.0986 times the x is just 1.0986x. And then 1.0986 times 2 is 2.1972. And then I still have this ugly decimal over here. All right, now let's just continue solving in the normal way. Let's subtract this value here from both sides. And we'll have left 1.0986x. And then whatever this is over here on the right, when we subtract these two, we end up with 0.636. All right, and the last step, let's divide out what's with our x. And we'll have our solution. And if we stick that thing into the calculator, we get 0.5789. All right, so let's look at a second example. So let's notice on this one, we know it's an exponential because we have a base, and then our x is in the exponent. All right, so let's just notice first, though, that this part right here is our base. We have the e, which remember is 2.718, and then its exponent. So we need to get that by itself. So let's first subtract 9, and we'll have 3e to the 3x minus 4. And then 21 minus 9 is going to be 12. All right, now there's still a number sitting in front of our base and our exponent, so we need to get rid of this number. Since it's being multiplied, we'll just divide it out, just as if that was 3x right there. And we get e to the 3x minus 4 equals 4. All right, so now we have the base and its exponent by itself on one side. Let's do step 2, which is to apply the natural log. Natural log, always in front on both sides. Now remember that the natural log was the logarithm of base e. So the nice thing is, when we're solving an equation that involves e as the base, the natural log and e cancel each other out because the natural log's base is e. They are inverses of one another. So when we put them together like this, if we have the natural log and e together, all we're going to do is we're going to get the exponent out of that, which makes this a much nicer equation that we can continue to solve. Now, let's go ahead and put natural log of 4, though, into the calculator, and we'll get what that is as a decimal approximation. That is 1.3863. All right, and let's go ahead and, oh, looks like I'm running out of room, so I'll add 4 and then move over to the right here. So I'm going to have 3x equals 5.3863. And then let's divide out our 3. And we will have our solution when we put that into the calculator. So let's see. That ends up being 1.7954. Now notice too, with the exponentials, we don't have to go back and check our solution as we did with the logarithms, because we don't have to worry about negatives or positives or even 0 when it comes to exponentials. We are allowed to have exponents that are negatives or 0.